welcome everyone. Thanks for joining me today. I didn't expect that many people, actually. So I'm Luca Nicoletti, an Italian Android engineer, currently based in London, where I work for Babylon Health. And that at the bottom one is my Twitter handle. Feel free to reach me out for whatever reason. As for the title, today I'm going to talk to you about two kind of newish things in the Android world, MVI and Jetpack Compose. First of all, I have a few questions for the audience. How many of you have ever heard about MVI? OK. Any of you have tried it out? Few people in production? OK, perfect. Same question for Jetpack Compose. Who knows what is it? OK, this number is getting bigger and bigger. Everyone have tried it out? OK, in production? I'm not joking. There's people already publishing application with Jetpack Compose, but yeah, whatever. So let's get started. MVI, it's an architectural design pattern, and it stands for Model View Intent. And it became popular in the web development, and it's getting right now into the mobile development. It follows some core principle. First of all, it's unidirectional. So the data flows always in one direction between components and never go back and forward. If a component communicates with another, it only sends data and never receives them back. It's immutable, so the state never changes. If you need to update the model of your application, you need to generate a new instance of the state. And it's reactive. And by reactive, I mean that it takes into consideration user input. And the user inputs are part of the pattern. And it's functional. It's based on function. And everything in the MVI should be represented by a function. Those functions are pure. So with the same input, we should receive always the same output. As everything in this pattern is a function, we can summarize it like this. A combination of functions, each one depending on the result of a previous computed function. Another way this pattern can be represented, it's kind of hard to see it here, but it's a loop. It's way easier to see it in this representation. It's an endless loop with no start or end. For now, let's assume it has a starting point, the user interacting with your application. This interaction produces intents or actions, which then, through the business logic of the application, manipulates the model. The updates on the model, so new instances of the model, updates the view, which is then reflected back to the user, completing the loop. I say that we're starting from the user interacting with the application, but we know that it's not always the case. There are some cases in which you could and would maybe perform some action even on lifecycle events or system events. So another thing to take in consideration, it's unidirectional, a component receives inputs and gives output. And it's a nice idea to have just one channel of communication between every component. There's an interesting talk made by Kushi Gopal at Mobilization this year, which explains it way in more detail. So as we have one channel to communicate from one component to the other, this is typically what it's being done in an MVI structure inside the view. So the activity, at the activity level, the line I want you to focus on, it's this one. We connect the business logic by providing the view, which is this represents the channel of output, and the render keyword instead represents the channel of input. So the user interacts with the activity producing intents, channel of output, and receive the updated state with the render function. And this is the render function. It receives a state, and based on the state, you usually hide or show some views, add item to a cycle view, delete them, show a dialog, enable or disable button, or whatever. Now, I say that the functions are pure, so there's no side effect. But we know that in a common application, side effects are a thing. We can't avoid them. So MVI, at least, tries to force you to be aware of side effects. So you have to declare them. Just one last thing before we dive into Jetpack Compose. At Babylon, we've been building an MVI library, and we've been testing it and using it in production for months now, and we're open sourcing it. We call this library Orbit, and we're proud to open source it. We know that setting up a design pattern in Android, it's a lot of boilerplate code, so we want to help other developers to avoid that part and just go with and using MVI. So Jetpack Compose, it's a hot topic right now. Everyone is talking about it, writing blog posts and whatever. I'd like to start as Google developer does. Jetpack Compose is currently in a developer preview. Since when they announced it the first time at Google I/O this year, it's changed a lot. And changes are planned, and for sure that's going to be a huge update. It's before they're going to release it. Side note here, the code I'm going to show you today, it's gathered 1 week ago, so it's not the latest code, right after Kotlin Conf. And it's retrieved from the Android X master repository, not from the artifact they're publishing right now. I'll come back later on this. So what is Jetpack Compose? It's a modern UI toolkit. That's how they define it. And this toolkit allows us to use a declarative UI pattern. To better understand a declarative UI pattern, it's usually compared to an imperative design pattern. I'm pretty sure everyone right now knows this slide. Leland showed that slide in a few talks. It used this example to show you how a declarative pattern and an imperative pattern differs between them. I'd like to go with an easier example. So for example, if you want to have a tower of 3 blocks with a declarative UI pattern, you describe what you would like. So you would say a tower of 3 blocks. With an imperative one, instead, you have to specify how to achieve it. So you have to put down the first block, the second block on top of it, and then the third one. This is how you can achieve the same result if the 3 blocks are 3 text view, right now in Android with an XML file. And if any one of you is familiar with Flutter, this is how you achieve the same result with Flutter, which use a declarative UI approach. The code, for me, it's way simpler, way less, and easier to read and cleaner. And this, for reference, it's how you achieve the same result with Jetpack Compose. So back to what is Jetpack Compose. It's concise and idiomatic, thanks to the Kotlin language. In fact, it highly relies on some core feature of the Kotlin language, trailing lambda, data classes, and so on. And it's based on components. And those components in Jetpack Compose are function. So being them a function, they can't have properties, but these components can have a state. We're going to go back here to see how. And these components are meant to be reusable. So you should have core components, small components, which you keep reusing through your application in different ways. And it's also compatible. What do they mean? Back at Google I/O this year, they introduced this generate view annotation to use on those composable functions. And this annotation was meant to be used on composable function. And it would generate all the code necessary for you in order to be able to use that composable function as you would use a normal view right now in the XML file or also in code. Here I'm just getting a reference from an XML file, but you also could initialize it via the default constructor of the view. And last but not least, Jetpack Compose is unbundled from the operating system. Google is following this approach with more and more stuff, recycle view, constraint layout. They're not bundled in the system anymore, but they come as library. And this means that the version of the UI is not bound to the version of the system anymore, so this will allow Google to fix bugs and provides improvement or whatever. So to start using Jetpack Compose, it's really simple right now. It's 3 or 4 steps. So you have to enable this compose build feature, which is a new feature they introduced. You have to set both Java and Kotlin compilers to target Java 8. Gradle and the Kotlin Gradle plugin has to be, the version of the Gradle and the Kotlin Gradle plugin has to be higher than those one shown here. And then, as I said, you have to include some libraries in your application. So those are 4 of them. There are more of them. These are the core ones you need. I'm using dev03 here. I haven't checked this morning, but I'm pretty sure it's the latest one released. They're planning to release a dev04 soon enough, which will introduce some breaking changes I haven't applied yet to the code sample. So bear with me for this one. On top of it, you can't use your Android Studio version, the stable one. You have to download the Canary version because it comes with a plugin that enables Jetpack Compose to work properly. So this is how you set up Jetpack Compose right now. Before Dev Summit, so before they release the artifacts, you had to download the entire Android X master repository in order to try it. If you want to stay on top of the latest update, you have to do it as well right now. You can sync the repository every day and get the latest commits they have. They haven't set up a release schedule yet for the artifacts, so it can be that you have to wait like months for the next one. So to start using Jetpack Compose, they introduced a new function at the activity level, which is the set content. This function is meant to be used instead of the whole set content view function, and it's where it's where Compose starts. It can be compared to the coroutines launch function. And this set content function is an extension function of on the activity level, and it accepts only one parameter, which is annotated with head composable. Being it the only one parameter, it can be used as a trailing lambda, as it's used here. What it does, it's really simple, even if the code is not so easy to read. It retrieves the content inside the main view of the activity and calls the old-fashioned set content view to set the content as the main root view of the activity. Then it would run the composable function received as a parameter inside this root view, making it the main view of that activity. Now, you see coroutines here. Right now, Jetpack Compose, it's single-threaded, so it won't work with multi-threading. They're writing code in order to switch to multi-threading easily, so they're already structuring it in the right way in order to use it multi-threading. So here we can see that this function returns a compose into. The compose into function, so compose, first of all, is an object, so you can use compose into wherever you are without initializing it. This method is the way to initialize a composition. The composable function provided will be executed inside the container, which is basically the root view of the activity. And this method, it's the opposite of the compose.dispose composition, which is this one. So dispose composition is meant to be used to release resources. For every call to compose into, it's important to have an equivalent call to dispose composition. And for equivalent call, they mean with the same container. Or else you can have memory leaks in your application. So composable annotation meant to be used on composable function. So composable function are normal function, but they have these extra capabilities of keep in the memory the last call at that position in the call graph. And they can be reinvoked at any time. The first capability, it's what they call positional memoization. And the second one, it's called recomposition. So this is an example of a composable function. As you can see, it's really a normal function with just an annotation. So you can't use composable function outside an active composition, which is what start from the composing2 function. Once you annotate your composable function, your function with composable, you can then call other composable function inside of it. Another great annotation they created, it's the preview annotation, which allows you to see a small preview as you can now see from the XML file inside the Android Studio. This annotation is quite limited for now. It can be used on functions that accept parameters. So if your composable function accepts any input, it can be previewed. What you can do and what they do in the sample application they're shipping, it's wrapping a composable function that accepts parameter with another one that has no parameter that sets up default value for the parameters and provides them to the function in order to have a default preview. Another thing worth mentioning is that the preview annotation generates a small test file. I found it out by clicking on the preview in the Android Studio in the breadcrumbs. You can see that it's pointing to this test file XML. So the core component of Jetpack Compose, it's split in 4 fundamental blocks, which are draw, layout, input, and semantic. Draw provide a canvas and let you draw on canvas, whatever you want. It corresponds to extending the view class right now and overriding the onDraw function. The layout, it's used for measurement and placement of things on the screen. The input provides you input, so gesture made from the user. So it can handle draw, gesture, scroll, tap, and whatever. Semantic, it's gathers information of the view tree. It's built for testing and accessibility purpose. It's not clear how we could easily use this for accessibility, as for now in the code, it's only used for testing. So this is the text composable function, which it's the corresponding of the edit view in the current Android framework. And as we can see here, it uses the semantic draw and layout. It calls them one nested in the other. Here it's easier to understand. So first of all, it sets up the semantic. It saves how to draw this text view, and then calls layout, which position the text in the current position. This is the draw inside of it. It retrieves a canvas, and as you can see here, it actually paints on the text. And that's what almost every composable function does at the end. It just calls the draw composable function and draws on canvas. As it draws on canvas, there's no view hierarchy. This is a screenshot made the 2 or 3 days after Google I/O 2019. As you can see, no view hierarchy, even if the layout inspector can see a lot of views, maybe. We asked in the Kotlin Slack channel if there was something like debug bind size enable, which is a Flutter flag that forces the drawing of the bounds and padding of the view on top of the view themselves. It's not yet ready, but they've been working on it. And this is a screenshot made after Dev Summit. And as you can see, the view hierarchy is now recognized by the layout inspector. It's a big improvement, even if when you select a view, you don't really select the view. As you can see here, it's still recognizing the entire screen as that view, but they're making progress, and I'm quite sure before they ship Compose, they're gonna have something that at least allows to use layout inspector in a meaningful way. So I spoke about the function having a state. To set up a state, there's this function, which is state, which returns a memo, which is a positionally memoized result from a computation. And this computation, it's built using a state. The state, it's a class annotated as a @model. and it's meant to be used in the plus state and plus state for effects. So the unary plus overload, which is actually being removed, just unwrapped the composition, so it was resolving, so providing the actual value. So it was returning the state, basically. The model annotation can be applied to a class that should represent your application data model. The instance of this class will become observable from Compose, such as a read of a property from that class will trigger a recompose of the function. What it really does, it observes the variable of that class, the property, the variable property of that class. Here is an example. As you can see here, there's a var and a val. Pretty sure every one of you knows the difference. So it's a model annotated class. So Compose will observe only the isDone variable and will kind of ignore the description, as it will never change. Once the isDone is changed, the composable function that is referring this property will be recomposed. Another note here, maybe not so important, but for now, model annotated class can support inheritance. If you try to do so, you get a compilation error. They're working on it, and there are plans to make it possible, but with no defined ETA for now. You can implement interfaces, though, so that's possible if you need something. So now I'd like to go through some components that they're shipping with the core library, just to show you how you could compose a kind of complex solution with using small function, and also to help you understand better how it's working. So this is the REPL function. The code is not that much. I know you can't read it. But if any one of you knows why it's called REPL rect, please shout it out, because for me it's not a rect. Well, whatever. It starts by setting up some state. First of all, it set up a radius, which is a state. The width density function returns a state. It set up a state which represents the state of the button, so it's either pressed or not, and then set up a transition. It's actually set up memoizing it. This memo, it's used to avoid generating calling the create transition definition every time the REPL rect function is called. So as it's memoized, it won't be executed every time. It then set up some callbacks on press and on release in order to update the status of the REPL. And it wraps everything in a press gesture detector, which is from the input fundamental blocks I showed you earlier. There's a container, which is from the layout, a transition, which is what creates the transition. So that's the function that updates the radius of the REPL rect, and then calls this REPL rect from state, providing a state as input. As this is another composable function that receives a state. It retrieves where the tap is being performed by the user. It sets up a paint in order to draw on canvas and retrieve the radius. This radius, as you can see, it's a state retrieve. So Compose start observing this radius. When it has everything it needs, it calls the draw composable function, which provides the canvas and just draw a circle at that position with that radius. And as this radius is being updated by the transition definition, every time it is updated, the draw function, it's being recomposed. And that's what it creates the animation of the circle expanding. Now, dialogues, there are a few reasons because I'm talking about dialogues today. The main reason it's because it uses a lot of lifecycle events in the new Jetpack Compose way. And also, it's kind of an edge case for Jetpack Compose. This is the code, not that much. It's a composable function which accepts an on-close request in order to notify whoever used this dialog function and it accepts a children. Now, Clara at KotlinConf explained why they're going with this solution to provide composable function. They're just accepting a children, which is a composable function, which at the end, it's what is being drawn inside this frame here. But they're not using any limits, so you can provide whatever you want. You can draw a circle, literally whatever you want. This is the dialog function. There's another composable function, which is material dialog, which instead accepts a title, a text, and 2 buttons. But they're giving you completely freedom to draw on that frame. So it retrieves the context. That's how you retrieve the context inside a composition. You don't need to provide it from the outside at every composable function. It memoizes a dialog wrapper, and I want you to focus on this dialog wrapper thing here. We'll come back later on. Now, going forward, it set up 3 lifecycle events in the new Jetpack Compose way. And those 3 lifecycle events are on active, on dispose, and on commit. So on active, it's an effect used to observe the life cycle of the composition. The callback will be executed once initially after the composition is executed the first time, and will never be called again. On dispose, it's the opposite of the on active. So it's what it's being called when the effect leaves the composition. This on dispose callback, it's what gets triggered when you call compose.dispose composition. On commit, it's being called every time the composition commits. So if any variable is being updated, compose call on commit. And as we can see here, on the active, the dialog is being shown. On the on dispose, it's being dismissed, and what's inside the frame also is being dismissed by this dispose composition. Instead, on the on commit, we're updating what's inside the frame. And now I ask you to remember the line of dialog wrapper. In that line, it could look like a composable function, but it's actually initializing an instance of this class. And this class inherits from dialog, which is actually the dialog we are already using right now. This is because dialog requires the windows of the activity in order to be able to draw themselves on top of everything else. So the roadmap here, it's not clear for me. I don't know if they're gonna keep this solution or if they're going to change it and update how they're displaying the dialog in Compose. This is not the only view which is using old views. There's also the web view, which is basically a composable wrapper function that at the end calls the current web view and displays it on the screen. So now, what if you want to modify your composable function? I say that those composable functions are meant to be reused across the entire application, but I'm pretty sure you don't want to use them every time in the same way. So they introduced this modifier thing. And a composable function that has a modifier can be considered decorated or wrapped by a modifier. You can combine multiple modifiers by using the unary plus, but keep in mind that the order is significant. An example of a modifier could be some padding. You have a text function, but sometimes you want to add some padding, and sometimes you don't. So if you want to wrap with some space, you just need to provide the modifier to the composable function. If instead you want more than one modifier, just a plus. So see the modifier as another composable function. In this case, you have your size effect, which is then wrapped by the layout padding, and at the end wrapped by the layout gravity. So it's first the rightmost in the chain and then the leftmost. So it wasn't always like this. When they released Jetpack Compose, back at Google I/O 2019, padding was achieved by a composable function, and that was the signature. It accepted a children, which was your composable function that you meant to wrap. And that's how you would use it. So it was actually a component. There was some problem, though. How would you expect this function, this padding function, to work? A text above the other, one at the start of the screen, one at the end. So padding was not a layout function, so it didn't know how to draw multiple children. So what actually happened here was that the two texts were overlapping one on top of each other, and on both of them the padding was applied. Now let's see how we could use Jetpack Compose and MVI all together. So both of them, as I show you, start from the onCreate of the activity. That's how we start. We call the set content in order to start a composition using Jetpack Compose and composable function as views. And then we have our composable function, which represent our screen, main screen, that accepts some processed intents, and the publisher, just to link maybe some if you have some buttons in that screen, you can then produce new intents by pushing them in this reload, which I haven't updated the name, intent publisher. So this process intent accepts some intents, which is an observable on the intents of that screen, and returns us a state. So as soon as we receive these intents, we subscribe to them, providing an intent observer, and we return a model state. This So this model state is an effect on the view state of that screen. And this effect is a positionally memoized computation of the view state. So at the end, we're returning a view state. So let's see, we could set up our result by using the state function, which returns a state, which is wrapping our view state with an idle or default or initial value. We set up a disposable, and then we're using the lifecycle events from Jetpack Compose. On the active, so when the function first reaches decomposition, with our intent observer, we apply our business logic, so firing API calls, updating the state and whatever, and we subscribe to them, updating the result every time. So every time a new state, it's being emitted by our application, by our business logic, we update this result. On this pause, we just clear after ourselves, and we then return the value inside the state, which is our view state. So the main screen function I showed you earlier, it's a composable function. And let's say that we're using some classes, so different instances of this view state. This function just go through every possible instance of this state and draw using other composable function to draw what actually is needed on the screen. For example, if we're in an in-progress state, we just show a circular progress indicator. That could be a login screen here, so you could have a column with two text, one for the ID, one for the password, and a button that fires an API call in order to log the user into your application. So being it a composable function, which accepts a view state that is wrapped by a state, as soon as the view state is updated, so as soon as our business application emits a new value, this function is then recomposed. So if the view state changes from in progress to from idle to loading or to completed, our screen is being updated. As we can see here, we have a bunch of functions, one nested into the other. And so that's all the code that's going to be in our activities. Apart from that main intents, which is a sum of all the intents that can be produced by that activity. If you're familiar with Eric's Java, it could be just an observable.from and the list of all the intents that can be produced by that activity. So if we go back to one of the first slides I showed you today, which represented the MVI pattern, by selecting this color and applying to the other function here, we see that we reached a complete functional approach, obtaining a real MVI pattern that's only composed by function and nothing more. So last minute changes. Now, you saw a lot of unary plus in my slide. It's not in the code base anymore, so just get rid of it. Bear with me, I didn't have time to go through all the slides and update and check if the actual code was working. All the code I show was working before the update. So yeah, this was the tweet by Linand. Breaking change. Yeah, no one understood the unary plus. They didn't either, actually, but yeah, there's no more the unary plus. The change looks really simple. If you have an effect off, you just get rid of the effect and now have a function which is a composable function. Side note, composable function couldn't accept a return type before this commit. They can now return something, whatever you want. On the other stuff, the changes is really simple. You just get rid of the plus from state. And yeah, if you had an effect off, you just get rid of it and call the composable function. And that's it. Another new thing is that they've been added UI tests for Jetpack Compose. So JetNews is their showcase application. And they started using UI tests on JetNews. And this is one of the 2 tests they've added. They're really testing it. So there's this find by text function which accepts a string. And well, they're just checking that this view, it's displayed. The interesting thing here is that they're not using Espresso at all. This is a unit test. So we can now start testing our view component of our pattern without using any emulator at all. Well, this is the text, find by text function. Just go through the view hierarchy, the view tree, and return the first node that has that text. Now, if anyone is wondering why it's called Compose, this is the answer. So first, initially, it was a class-based instead of function-based. And there was this abstract method on that function, which is the React's render or the Flutter builds method. But they were trying to find a name, but they didn't want to use build because it wasn't returning a build object. And so he came up with this compose, like composing a letter. And they literally swap between using classes to function without saying anything, like, yeah, just this change, that's it. But yeah, that was a curiosity. If you want, you can just follow me on Twitter and read the entire thread. It's like 6 or 7 tweets by Leland explaining the real scenario. And yeah, he took credits for the naming. Well, that was it for me. Thanks for joining me. If you have any questions, feel free to ask. It's late. Ooh, there was a question?
Hi.
Yeah, it is working, I guess.
Is it working? Do you hear me?
Yeah.
So in your example with the main screen, when you're receiving new view states, you're composing whole view and rendering it immediately.
Yep.
Did I get it correctly? So you were not referencing existing view.
No.
How would you solve the situation when you when you receive new state, if you don't want to completely render a new view, but do some animation like transition or something like that as a result of a state change?
So I would use multiple nested state. So you would have the main screen state, which has, for example, for a tweet and the answers, which has the tweet state and the reply state. So I would render the state as the tweet state as soon as I receive it, show a loading because the other state is loading, and as soon as it's received, as Compose knows that the tree is not changed anymore. Even if in the main screen composable function I'm rendering it over again, Compose knows that it's not changing. So it's always the same view hierarchy for the first part. What has changed is the second part. So it will skip the first part, go through the second part, and update the second part only. So it's completely handled by Compose.
So it detects what is the same as a previous view tree.
What I show you, it's basically just an half of Compose, which is the Compose UI part. There's also the Compose runtime, which is actually where all the magic happens. So the @composable function actually injects some other properties inside the application, which is Compose, which has it memorizes the view tree and stores some keys for every composable function that's being rendered. So by providing those keys inside the view hierarchy, it can understand which one of them is being updated and which one is not.
Okay, thank you.
More questions? No? Thank you very much, Luca, for a good talk.